Great. So let's take a chance to look at scales in D3. And particularly, we already did talk about scales, but let's take a look at nonlinear scales and see what they can do for us. So here, this is D3 scale module, right? We've seen this before. If we scroll down, read about scales. I did want to point to the, in here, it points to the Introducing D3 Scale post by Mike Bostock. And this is really a great introduction. Right, and if you want to read through it, it's not a terribly long read, and I do recommend it. Going a little deeper, right, you can see that in the API reference, right, there's continuous scales, which are what we've worked with in the past, and we've really only touched here on linear scales. So we'll take a chance to look at a log scale today, and beyond that, there are a lot of other interesting scales. One of them that I want to bring your attention to is something like the band scale. These depend on your type of data, but here the band scale is something that would be useful for making a bar chart, for example, because you might wonder, okay, well, I have data and I want to encode the X dimension onto a bar chart. Well, this will accomplish that scaling for you. So this is fundamentally a scaling problem. So there's help utility functions in here, helper functions, that'll scale the data in really any way that you could need. There's circular scales and anything that you might find useful. So jumping to the example here, I've loaded up the same data we were looking at before, where this is the Slack messages from the noise channel in the iSchool Slack. And so just to get a look at the data that we're actually looking at here, this is the JSON, right? So we get the text and an anonymized user, and timestamp, what type, etc. And of course, the first things are people joining the channel. So if we jump back, I've gone ahead and done some of the data processing. We have our standard X and Y linear scale set up, mapped to the range of our visualization here. You can see we've used some margin to give the graphic some space within its total dimensions. We've got the data loaded up, and here I've gone and done some of the data processing. So just to introduce this a little bit, we have the users, where I went and extracted that key from the data JSON. And then two other steps where here message counts is I think of it as a Python dictionary. Of course, it's an object in JavaScript. But what we've used this data structure to efficiently add up the users. So we created a key for every user. If it didn't exist, we created one, and we add up the number of messages per user. So keys are users, and the values are the number of messages. So we just have those in there, and then we can go ahead and extract this into a list, and we can from there we can go ahead and sort it. So what we want to look at here ultimately is the distribution of messages per user. And what we're going to focus on looking at is a rank frequency distribution. So if we can sort users by the number of messages on X, and we plot the number of messages that they have on Y, then we'll be able to look at this distribution from a power law perspective, and maybe we'll even see a scaling break. So to get started, we have our data loaded up, right? So the next step is pretty simple here. We have the data loaded, so we're going to want to actually adjust our scales to account for the length of the data that we end up with, right? So we can set the x.domain, right? And we're going to want the domain to go from 1 to sorted.length. So that's going to be the length of our data. And the y, we're going to want to go from 1, and the least number of messages will be 1 message. And we're going to want to map that all the way up to the maximum number of messages here, which is just going to be the first entry in the sorted, right, and the second value, because that is the message count. So we can store those, and pretty quickly we can go ahead and actually add our data to the plot, right? So if we go ahead and add our data as circles, so we'll go ahead and SVG select all circles. So we'll go ahead and grab the circles within the SVG element, right? And we can follow through with our data enter append cycle. So we'll just add data for the sorted array, right? We'll go ahead and create the elements that didn't exist, and on each of those elements we will add a circle, right? So if we ran this, we would get all the circles, but we just need a few attributes to put them on the graph, right? So if we give them a radius, we'll give them a radius of 1, maybe 1.5. You can play around with this, and we'll give them a x and y attribute, right? So for the circles, x is going to be the rank. So we want to plot the rank here. So we're going to want to use its position in this array. So we're going to want to use the I here, and we're going to want to scale it using our x scale. So we'll return x of I. So that is our x attribute, right? And for our y attribute for a circle, it's going to be cy, right? And we're going to want to set that using the number of messages. So here we just need d, the number of messages, right? And we're going to scale that by y of d. Right, so now we've added circles to this graph, right? So we can go ahead and see where the number of messages actually fell. And looks like they're all at the top. Cx, x of 1, d, and of course, yeah, one faux pas here, right? We need to use that first message. So here we go, right? And this is what it looks like. So down here at the first user, beginning where x has the most messages, and that scales away. Just to make this a little clearer, of course, it helps to have axes. We already talked about adding these, so just for convenience, I'll go ahead and copy these in. So if we add some axes to this graph, right, they're using our x and y scale, right, we can see where these points actually fall. So yeah, the most active user has about 700 messages, and it falls off pretty quickly from there. I can't see too many patterns from this type of graph, so this is the type of graph that if we're looking for a power law distribution, it'll help to see it on a log-log scale. Here we've mapped linearly using x and y onto the range, right? But for D3, if we want to go ahead and change our scale, right, we're going to want to use a log scale. So we can actually use just scale log, right? Similar to a linear scale, right? But it's going to adjust this using a logarithm. Because they're good people, right? It's a default base 10 log, which is what we're going to want to use. Makes the most sense here. So here we can just go ahead and adjust this to log. Pretty simple. And we can look at a log-log plot in x and y. So if we go ahead and run that, right, the scales adjust automatically, right? And we can see that the number of messages here is log scaled, so 4 e to the 2, right? Yep, as we would expect. And so you can see that the tick marks have also adjusted themselves to a log scale, so you can see what's going on here. And in particular, now we can actually see something about the data. So we can see that there is a scaling break here. So the first message is scale with some power law exponent, and then it tails off after that. So that's our data using a log scale.